Question 5. This question is about equilibrium 5.1. Complete table 2 by deducing the amounts in terms of X of the diester, water, and diol present in the equilibrium mixture. 3 marks. Okay, so the acid is clearly this, and the diol is this, the diester is this, and the water is this. Now we know which one is which. Now the equilibrium moles is what we're trying to find for each one for 3 marks. So if this is the equilibrium moles of the acid is X, equilibrium moles of this is just going to be that divided by 2, because that's 2 moles, that's 1, it's 2 to 1 ratio. So all it is going to be X divided by 2. And I think that would be 1 mark. I think it's 1 mark per answer, because diol is going to be X over 2. Now the water is also a 2 mole ratio. So many people would be like, oh, so it's also going to be X, right? Yes, that's true. However, because we have this 1, and the change is going to be, because because in here we're adding X, here we're adding X over 2. Remember, in equilibrium, we're adding something on one side, and the other side we're going to have to subtract it. So in this case, instead of adding X, we're going to minus X, because it's still 2 to 2 ratio, so it's still going to be X is going to be 1 minus X. And here, well, instead of minusing X, because it's a 1, here we're adding X over 2, here we're going to minus X over 2. 1 minus X over 2. So 1 minus X over 2, 1 minus X, and X over 2. A bit of a bit tricky, but once you get your head around it, it should be good. Then it says deduce the structure of the diester in question 5.1. C7H12O4. So we've got C7H12O4. So we're going to have 4 oxygens, and we're going to have 2 double C double bond O. So it's going to be here, double bond O, here, oxygen, here, 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 and oxygen, here, here, and another double bond O. So we've got double bond O here, oxygen, double bond O here, and oxygen there. And this would be C7H12O4. And then 5.3, final part of question 5. A new equilibrium mixture of substances for question 5.1 is prepared at a different temperature. Table 3 shows the amount of each substance in this new equilibrium mixture. So these are now the equilibrium moles. It says it here at equilibrium, the equilibrium mixture. The value of equilibrium constant Kc is this. At this temperature, calculate the amount of water in this new equilibrium mixture. So first time I attempted this question, I was like, okay, if we want to try and find out moles, well, moles is equal to concentration times volume, so we want the concentration. Concentration is moles divided by volume. So where's the volume? Well, we're not giving it in the question. In fact, we don't need to do that. So we know Kc, so let's construct the expression for Kc. So Kc, remember Kc, it's going to be square brackets. I think you'll lose a mark. Yeah, you probably would if you don't include square brackets. So it's going to be CH3 COOH H squared times by HO CH2 3OH divided by H2O, because we've got 2 moles of it squared, and C7H12O4. C7H12O4. Now what we want to find is the amount of water, so H2O, the equilibrium moles of water. So we're going to have to rearrange it. So if we times by H2O squared times by C7H12O4, we'll get H2O squared equals CH3COOH squared HO CH2 3 OH divided by, well, KC, yeah, divided by KC times by C7H12O4. Now we know that we're already given all the values now, so we can quite easily calculate this out. So I'm pretty sure you do need to show the substitution, so let's show it. H2O squared equals CH3COOH squared, so the acid squared, 0.452 squared, 0.52 squared times by, yeah, I should probably include times here, times by the dial, which is 0.273, divided by Kc, which is 0.161, times by the diester, which is 0.971. So we've got 0.452 squared times by 0.273 divided by 0.161 times by 0.971. I get 357, but that's H2O squared. So we want to find out the amount of equilibrium moles, amount of water in moles of H2O. It's going to be square root my answer, which will give me 0.597, and that is the end of question 5.